Matt Phillips. This is April 21st, and this is my first video of FlightComputer version 1.0. This computer is based off of an Arduino Uno, as well as a few general hardware accessories and some custom programming. So here it is. This is the FlightComputer itself. It uses XV to transmit and receive wireless information through this antenna here that goes to a base station as seen here. Both of these are custom made. This base station has the XB USB interface inside of it and will communicate with this base station laptop. So we have the computer here, the custom mount made with PVC pipe and Velcro here, an APRS encoder that is a TinyTrack 3 hardware. We will look at that in a future video. The battery is from a remote control helicopter. It's Velcroed onto the back because I didn't have enough space in the chassis to actually include it. As I said, this is the USB base station, which we plugged into here, so we'll start with that. Plug that in like that, and I will now run the software for this. See if it'll focus. It's all I'm running is Minicom. For those familiar with Linux, I'm sure you'll know what this is. So. Alright, brought up Minicom. We've got our basic prompt right here. I'm waiting for the FlightComputer to start up. So, that is running through this, which also has a magnetic base to be stuck on a chase car and used out in the field. We will now plug in our battery. There it goes. Boots up. Puts up a nice little... Here it comes. This is our display. See if we can actually see it. It shows the current air temperature, the mean sea level altitude, the above ground level altitude, and the variance in feet per second. I know you can't actually see that data, but you can look at pictures for that. So that is now going. You hear the beep. The beep should change as it goes up, and then it should go silent as it goes down. The beep is set to get higher pitched as the variance increases. So as you go up faster, it gives a higher pitched beep. As you can see, the APRS encoder is blinking, which means it's trying to get a fix on the GPS signal, but right now we're inside and the external antenna is unhooked, so that's not getting a signal right now. Every 4 to 5 seconds, this FlightComputer is transmitting to the space station, and we are currently getting live data on the computer. Doesn't seem to be focusing very well on it, but you can look at pictures for that. So, we're currently getting data for the timestamp, seconds from boot, the air temperature, the both altitudes, the variance, and the GPS altitude is not currently being used. As that is being fed, we can send commands to it, such as mute, which disables the audio. You now notice that it stopped beeping. Now all of these commands are done wirelessly from that antenna to the space station, and both directions can communicate up to 1 mile. If I want to enable the audio, I I give it another command, and it starts beeping right up. I can also, with another command, enable backlight. As you can see, the backlight is now on. Make it a little bit brighter. There it is. See the backlight turn on, and the backlight turn off. Those are done with commands on the computer. You can see backlight 100%, backlight off. I can also put the computer into other modes. See if GPS mode will work. When I feed it the GPS command, it resets in GPS mode, in which case it just reads off the GPS data, and I can change this to spit out the longitude, latitude, altitude, and any of the data coming in from the GPS. Once I reset the flight computer, it should automatically leave GPS mode and begin spitting out data again. There it goes. So now we're getting data again. Alright. That concludes this portion of the FlightComputer version 1.0 video. We'll show its APRS functionality in a future video. Thanks for watching.